Good evening and welcome to our Ask and Learn session presented by Hydron Module. Today's topic will be, how does geothermal work where I live? A very popular question. So a little bit about us. I'm Kyle Smith, your moderator or host. And then this evening, Brian Erlob will be your presenter. Before we get into our tonight's session, let's get into a little bit about Hydron Module systems. They're built by Intertek. We've been in business for about 20 years, with Hydron Module being around since the late 80s. All models are manufactured in Mitchell, South Dakota, with our corporate headquarters in Greenville, Illinois. Products are sold throughout U.S. and Canada, even a little bit in the Caribbean islands. Residential and commercial customer and product focus is our main goals. So let me hand it over to Brian.
Thanks, Kyle. For everybody that's in attendance, to make the most of your webinar, if you could, please take some notes. And the name of the session is Ask and Learn. So, of course, we'd like you to ask questions. At the end of the webinar, there'll be a time when you can ask questions, and we'll have you write that in on your sidebar. And then, of course, you can research and review all of our websites, YouTube. We've got a lot of great videos out there that can help you learn and understand geothermal. Okay, the first thing I'd like to talk about is the overall scope of geothermal systems. There's a lot of maybe misconception out there with geothermal, and there's two really different kinds. Some people think of geothermal as the heat that's coming from the center of the earth or the core of the earth. That's what we call high-grade geothermal. That's really only found in very small portions of the country, primarily out west, and that is used for electric generation. They generate steam that's very hot, temperatures coming from the ground, generally in the form of steam. What we're going to talk about tonight is really geothermal systems for heating and cooling. And that really is a indirect solar system. What we have is we have the sun's energy that's obviously warming the earth, and about half of the sun's energy actually penetrates the crust of the earth and is stored there like a solar battery. So the key to our system is really being able to tap into that solar battery and try to utilize that energy for both heating and cooling. The great thing about the technology is it's a heat source in the winter, and it's a great place to deposit heat in the summer. As you can see by this graphic here, the ground temperature throughout the United States is somewhere usually between 40 and 75 degrees, depending on if you're in the northern climates or if you're in the southern climates. And if you notice, most home comfort levels are somewhere around 70 degrees. 70 degrees is very close to the average ground temperature throughout the United States. So rather than in the wintertime trying to heat your home from minus 20, okay, we're going to heat your home from somewhere between 40 and 75 degrees. Naturally, heat always moves from hot to cold, okay, so the lift to take that energy and put it into the home is takes much less energy than if we were to do it from minus 20 degrees. And like I said, it also works in the summertime. So now that ground is a nice cool place, much cooler than the outdoor air temperature. Throughout the country, air temperatures can reach upwards of 95 degrees. And we're trying to maintain a comfort level of 75 degrees within the home. And as you can see, the ground temperature throughout the country is somewhere between 40 and 75, depending on your location. That's really what we're here to talk about is, does it work where I live? And you can see that throughout the country, and I'll show you another map here shortly, that the ground temperatures are very stable, very even, and very close to the comfort level temperatures that we need in our home, which makes it much easier and more efficient to be able to heat and cool throughout the year. So here's a map of the United States. And as you can see, the farther north you go, the ground temperatures do cool off. And if you were actually to take the average air temperature anywhere in the world, okay, for 1 year, take the average air temperature, go down 20 feet into the earth, that's what the mean temperature of the soil will be. So as you can see, you go farther south, the average ground temperature warms up because your average air temperature is much warmer as you get closer to the equator. The further away that you get, ground temperatures cool off. But the great thing is those temperatures are still within the range of the geothermal system's operation point, and also much closer to the comfort level that we need in our home, which is generally around 70 degrees. So the key really to the system is we have to be able to take that energy that's stored there by the sun. We have to be able to transfer that energy into the home. Or in the summertime, we have to take it from the home as the sun's warming the home and the internal occupants are warming the home, and we have to deposit it out into the earth. So we need a means to do that, and that's where the ground loop comes in. This is really the heart of the system. We have lots of different options of ground loops, and it really varies, again, depending on your location, but really it varies mainly on the size of land that you have available, and then also the cost in your region and what it costs to put the systems in. So the first one we're looking at here is the pond loop. The pond loop would be if you have a private pond on your property, the pond is of adequate size. We're going to bury pipes or sink pipes to the bottom of that pond, trench those into the home, and that is now your heat source and heat sink for your geothermal system. The next one we have here is a horizontal loop. And a horizontal loop is where we would excavate or dig a trench into the earth, usually somewhere between 6 and 8 feet down into the earth, and we're going to bury those same pipes. This usually takes a little bit more space, on average about an acre of property that the house is sitting on, including what the home is sitting on, and that gives us enough room to put in the loop. And the last one we're going to cover is the vertical loop. This is generally for the more suburban areas where you don't have a lot of property, maybe a quarter of an acre to a half of an acre, and now we're going to drill vertically into the ground with some type of a drilling rig, somewhere between 100 to 200, 250 feet, just depending on the soil conditions and how much heating and cooling that we need. And then again, all these systems will be buried at about 5 to 6 feet, so you don't see anything when everything is finished and complete. And now you have an energy source all year round that will provide for your geothermal system. Why would I choose one over the other? Again, we have 3 different options. Well, it really comes down to space, land availability, your region, okay, and then economics. What does it cost? They all perform equally if designed and installed properly.
Hey, Brian, wouldn't you say that vertical systems are most popular?
Yeah, it's a good question or good point, Kyle. Vertical loops are definitely the most popular, but I would say it's very close to the horizontal loop. When you get into the rural applications, your horizontal loop, you've got a little more space, costs a little bit less, so we tend to see that more often. The vertical loops, again, are going to be where more people are, which is your suburban and urban areas, and of course all of your commercial type applications would be a vertical loop generally. Okay, so let's look at the overall system and the components and a little bit about how it works. Now we've got the loop in the ground. We've also got a geothermal heat pump unit that's inside the home. And then we've got some small pumps that circulate the fluid. The fluid is a water-based fluid and possibly water and antifreeze, depending again on your region. The further north you go, your loops get a little bit colder because of the design temperatures and the ground temperatures, and so we add antifreeze. But it's a very basic system, and this is all it takes to do both heating and cooling with a geothermal system for your home or building. So what about my home? How does it work? Where does it work? Different applications. Really, geothermal is scalable, so it works in all sizes, and it works for both new construction and retrofits or existing structures. If we look at homes, it's a great time to do geothermal when you build a new home, primarily because of the financial aspect. When you can roll it in your mortgage rather than paying for it all up front, it makes a lot of sense to do it up front. But certainly existing homes are a prime candidate for geothermal. So really it boils down to, do I have enough space to put a ground loop in? And then what type of heating or cooling system do I have, and can I match up the system that I would like, in my home? So do I have radiant floor? Do I have a ducted forced air system? Maybe I've got a boiler with radiators or baseboard radiation. So those are all things that have to be looked at, including things like your electrical service and other things that may or may not have to be upgraded. But it works great for all applications when it comes to residential. And again, it works from small homes all the way up to large homes. We've done homes that are less than 1,000 square foot. We've done homes that are net zero and very energy efficient, built with ICF technologies. So we can scale this down to meet any small, highly efficient home application. And we've also done homes well in excess of 6,000 square feet, older homes, farmhouses, new homes. So large and small, new and old, geothermal works for everybody. Again, it boils down to really land availability and just the right application. And of course, energy costs also do play a factor. And there's also lots of other applications and other structures. We've done things like farm shops, churches, garages. When you get into the commercial sector, we've done office buildings, retail stores, convenience stores. So the great thing about geothermal technology is it's available everywhere. Okay, it isn't limited to one place or another. It works from, like I said, basically the equator to the North Pole. It really just determines, how much loop do I have to put in the ground, depending on where I'm at in the country. And that goes back to your designer, your installer, and it works for all different sizes and structures. We can do geothermal in very small spaces and all the way up to institutional, industrial. The largest geothermal projects in the country are college campuses where they're doing entire buildings across the campus. So it's very scalable, and like I said, it works everywhere. So that's really it. Very short webinar. I appreciate your attendance. Thanks for joining us. A couple of things. Kyle, do you want to take it from here?
Yeah, thanks, Brian. So take some time now to ask us any questions that you might have. I can see we already have a few coming in. And then if you have to get going, check out our website at hydronmodule.com and check out our savings tool that might interest you, or check out a dealer in your area. Next, maybe you want to talk one-on-one with us, actually even me myself, on your home upcoming project, or possibly where you go to work or where you go to church. Then check out this webinar actually coming up here, and we're going to post that to our YouTube channel. And we're actually doing more webinars coming up in January and throughout the 2016 year. So I'm just going to pause for a second here, let the questions load up. All right, Brian, here's our first one. I live in a small lot, about 1/4 of an acre in the city. Is that enough room for the loops?
Well, that's a great question. That's an urban area with a 1/4 acre lot could be difficult depending on access to your yard. So if you have trees, if you're very close to your neighbors, if you live in an alleyway maybe, depending on where there's overhead power lines. So when you think about access to your yard, you have to think about a drilling rig being able to get into your yard and drill vertically into the ground. So it generally isn't, can I fit the loops in? It's, can I get the machine in to actually put the holes in the ground and put the pipe in the ground for the geothermal system. But generally a 1/4 of an acre would be sufficient enough.
Oh, okay. That's true. Actually, another question that goes right alongside with that. Can you put the loop field underneath the driveway?
That's another great question. Vertical loops can be put underneath the structures, driveways, parking lots, but that would be the only style loop that you would want to put underneath a hard surface. Horizontal loops are close to the surface. Generally, it's that 6 to 8 foot range. And so any type of a hard surface, number one, doesn't allow any moisture penetration from rain. And there's two things that really go into a good performing loop, but it's moisture and then and density. So when you're stopping the rain from penetrating the earth, that moisture doesn't get down. It affects the loop operation. So you wouldn't want to put a horizontal loop under the driveway because you're stopping that moisture from penetrating. But a vertical loop, because you're drilling straight down, you're generally going to be into a much more moist or maybe even water table. when you drill down that far. So that doesn't have any impact on the loop field. And of course, if you're in the northern climates, then you're also removing snow in the wintertime. And when you remove snow, the frost goes deeper. So then you have to be concerned with that. So it just depends on your region, but it's not really a great idea to put a horizontal loop under a driveway.
Okay, well, here's another question, Brian, in regards to more vertical loops. So the question is, you mentioned the depth of the vertical loops are 100 to 250 feet. What are the determining factors for the depth?
It's really just drilling conditions and, in soil conditions. So generally, what most people end up doing is they drill through what we call overburden, which is your sands, clays, loams, and that nature. When you get into drilling through hard rock, the cost goes up. So let's say you plan on drilling to 200 foot, and that's a very common number throughout the country, 200 foot or so. Well, if you hit bedrock at 100 feet, rather than keep drilling into the bedrock because the costs go up, you can just drill more holes at 100 foot. And so the bottom line is it's not necessarily a depth that we're trying to achieve, it's how much pipe we need to put in the ground for that particular home or business. So it just all comes down to economics, drilling conditions, and space.
Gotcha. Okay. All right, here's one for the north climate in regards to heating. Would supplemental heat be needed for geo in North Dakota? Question mark.
That really goes into the design of the system. It can go both ways. You can actually see supplemental heat very commonly used in the northern climates, but also, especially when it comes to radiant floor applications, there's a lot of systems that are designed where geothermal can handle 100%. So again, this goes back to designing the system properly, making sure the homeowner understands what they're getting, because you can do it either way. It really comes down to economics and, how much do you want to spend for the system. So if I want to do 100% with no supplemental heat, it's going to cost me a little more because I've got to put a little bit bigger system in. So economics, maybe if it's a retrofit, the existing ductwork might have something to do with how big of a system that you can put in. So then it goes back to, all right, now I've got to have supplemental heat because I just can't put in a large enough unit to do 100%. Okay, so, again, if it's a lot of factors, if it's new construction versus retrofit, if it's, the economics of it, what type of heating system am I going to have, radiant floor, forced air. Forced air is really easy to put a little bit of supplemental heat in. So there are a lot of factors, and the best thing to do is just talk to your dealer and ask them why they're sizing the system one way versus another, and hopefully they'll have a good explanation.
All right. We got a few more here. This one comes from Western Kentucky. I'd say this is unique. They have a very rocky hillside with total shade, and then have about 1 acre, and they're within about 500 feet of the river. Could the rocky riverbed be inferior, or the riverbank often has huge boulders? Could this be doable?
Well, that's a great question. Somebody would really have to look at that. That's very specific. Generally, boulders, and especially if they go into the earth, any depth, if you've got a lot of big boulders in the soil, that can be very problematic. Drilling vertically, drilling horizontally or directionally, unless if you've got enough space, it sounds like an acre. Was it an acre? Kyle, was it an acre?
Correct.
Yeah. So
correct. Yes.
They could actually excavate that with a large excavator, take the boulders out, put the loop in, and then bed it back in with good soil. So that's a good possibility. However, when you're near the riverbed like that, a lot of times you're going to be in a drier soil until you get down to where the river kind of equalizes with the soil. So again, you just have to get somebody out there and take a look at it. It's certainly doable, but I'd be very cautious and make sure they do it. Obviously do their proper design and due diligence.
Right. Brian, I'd say we run into this a lot out west, and even in the mountains and throughout the Northwest. That's a very common question out there. Another question we have, we don't use that much heat in the Fort Worth home we live in. Does geo make sense here?
Yeah, absolutely. Anytime you're doing heating or cooling. So I'm assuming in Fort Worth, you're going to be at a lot more cooling dominant. And so this system works much better than a traditional air conditioner. Back to those earlier slides, that ground temperature is going to be more consistent and a lot cooler than your average air temperature and certainly your extreme air temperatures during the middle of summer. So your energy savings are going to be much greater than if you put in a high efficiency air conditioner. This is the highest efficient air conditioner you can possibly put in because that consistent, even ground temperature that's much closer to the temperature that you're trying to keep your home, and you don't have the big swings of the extremes all summer. And then, of course, if you do need a little bit of heat, fantastic. The unit automatically switches into the heating mode when needed, and now I can take a little bit of that heat out of the earth. So it works great.
Right. Perfect. Last question, Brian. We have a question about whenever you brought up the snow melt earlier. Tell me a little bit about snow melt and how it works with geo.
Yeah, snow melt is really tough with geothermal, and I say that because it's primarily just the amount of BTUs that it takes to melt snow. When you're trying to even do a sidewalk, you think about an average home. Let's talk about an average built home. It usually requires about 20 BTUs or so per square foot to heat that structure. When you want to melt snow outside, it takes over 100 BTUs per square foot. So the impact or the size of the system gets so large in order to do it with geothermal that the cost benefit just isn't there. With a boiler, you can get a boiler, up to 400,000 BTUs, and it doesn't cost you a whole lot more than one that's 100,000 BTUs. With geothermal, when you go from a 4-ton unit to a 20-ton unit, there's a tremendous increase in cost. So, the cost benefit isn't there. It's certainly doable. I mean, commercial applications, I see it quite often, primarily because they're rejecting heat from the building all year, even in the winter. So then it's a prime candidate to take that heat instead of putting it into the earth. Let's put it out and melt the snow on the sidewalk. But if you're doing a home and you want to do a driveway, and I've actually been involved in a few projects, usually after the first winter they turned it off and they don't ever turn it back on, mainly because of the cost. And it does upfront cost. Number one is really tough to overcome. Number two, just the operating cost. You're heating Mother Nature. You're trying to heat outside. And so, and there are actually some regulations in certain states. For instance, Wisconsin doesn't allow you to do any snow melt with fossil fuel. You have to use a renewable energy like geothermal, but it just isn't very common because it takes such a large system.
Great, Brian. Thank you very much. I think that will conclude our questions for today. And thank you very much, everyone, for joining us this evening. And please check back for upcoming webinars. And again, if you'd like to check out this webinar here, we have recorded it, and you'll be able to check that out on our YouTube channel. So thank you very much, and have a great evening, and have a wonderful Merry Christmas.